So we're here today to talk about some issues that we have when tools are brought in from our customers and what to look for, what we can give them for information to help them out to keep their job sites running smoothly. And one of the major ones that we see and that we come into contact with is
Power issues.
power issues. Yes.
All of the power issues. Be it the garters, be it from the brushes, be it from portions of the motor.
Yes. So we'll go into those a little bit more and show you what new ones look like and what the burnout ones look like and what to look for when, to avoid that, I guess is the best way to say that.
Yep.
So oftentimes and I think this is just something that we do as humans, when we buy something, we don't pull out the owner's manual. We don't read it. So we end up doing things like this instead, right? Because most people are visual,
Of course.
audio.
I am, for one.
And when I say visual, not like the reading visual, I mean the actual seeing it, right? And that's why we are doing this today. One of the biggest things that we always say to our customers when they call in and they're having issues with their tool, which we will cover what it sounds like and what to look for, is what are you plugged into? And a lot of the times we hear it's a welding generator, which is common because
Yes.
when it comes to structural bolting, there's two ways to do this. There's bolting or it's welding.
Yep.
And usually there is a welder on site.
Which makes it pretty convenient.
To have a welding generator. Exactly. But most of our owner's manuals, it's page 14 that says do not plug into a welding generator. And that's what they end up plugging into because that's what's on the site. And so we're here to educate you guys what is clean power, as we call it, what to plug into, what not to plug into. So starting there, first question we always ask is, what are you plugged into? Well, this is what we use as a good indication of what will work and what won't work. Do you want to go over what we have here in front of us?
Sure. This is our 2200 Honda generator. It's one of those quiet little guys, so we like running those for sound alone. But unfortunately, they come with an eco mode, and with eco mode, we don't like it on. When it's on, it doesn't regulate the power going out of it as consistently. In that, if it is on, it's going to fluctuate up and down. Provides kind of bad power to the motor components and will burn them out over time with inconsistent power. If you have a consistent drive and power, these things really do, they run beautifully. So we want to make sure that it is consistent, eco mode is off, and that should prolong the life of the tool.
Yeah. So I like this as an example. So we talk about that. I was at a job site doing some training and I had just said the same exact thing. You don't want to run it on eco mode, and it was on eco mode. So I was doing a demo for the tool and I went to tighten the bolt and you could hear the generator kind of like bog down and then come back up. And I was like, oh gosh, there it is. And not only did I hear it, it didn't go to full tension on the skid more. And the foreman of the job site said, oh, did you hear that? And all the workers were like, yeah. And he said, what does that mean? Nobody spoke up. And then I said, it's on eco mode.
Yep.
And he was like, yeah. And I said, so that's what I mean. So you see how this didn't get to tension.
Yep.
And you heard the generator bog down.
So what the generator's trying to do is feed consistent or equal power based off the draw that's being drawn out of the outlet, right?
Yes.
So as you're plugged into it in eco mode, it realizes that draw coming out of the motor itself, out of the outlet itself, and it's trying to compensate for that. So it's now elevating the RPMs in it. Now that's giving a way higher voltage reading into the motor of this tool, you know. It's a 110 volt motor at 15 amps. If it fluctuates up above that, down low, it's going to add some type of resistance or wear to these motors, which is why it's so important to keep it off eco mode. no welding generators, no boom lifts.
Yeah, and the boom lifts is a very big, I want to say controversy, but they say, oh, it tells me it's this, it gives out this, but it gives that power out, that amperage out, those
Hmm.
wattages out until it doesn't. So
Of
it's
course.
never consistent.
Yep.
And that's one of the things that people don't understand. That's why we tell them not to plug into a boom lift. Because even though it says it gives that out, it
It
doesn't mean that it always does. It's
doesn't
not
always.
always
It's
consistent.
based off the wear of the batteries in the thing, whether
Yeah.
those are that's connected to some type of shore power, giving it power. They think it's kind of regulated, or there's like a capacitor in it that filters out the amount of voltage. It doesn't do any of that. It's literally just like running an extra extension cord on it. It's going to add a bit of resistance.
Right. Yeah. So those are the big things to think about and to look at.
Mhm.
And a lot of the times too, I get why people run these on eco mode. They want to save gas. They want to, just
Sure.
kind of conserve energy or whatever. So they sometimes forget.
Yeah, I mean, it sounds nice, eco mode. It sounds like you're doing something for the tool, when in
Yeah.
reality, you're doing something bad for the tool.
Right. And one thing to keep in mind too is that it necessarily doesn't hurt the tool right off the bat.
Nope.
It does, but it'll still work for a little bit. So a lot of the things that we hear that when our customers call in, they say, my tool was working and then it stopped working.
Yep.
That is a good indication that it is something that they're plugged into.
Yeah.
Whether it's the extension cord, the whatever it is that they're plugged into for power.
I mean, based off of the wear of whatever generator you're running, or whatever power source you're running from, be it not from the line, from a normal power line, you got to factor in the wear of your power source itself,
Absolutely.
on top of the assemblies you guys are tightening out there. Whether it's lubricated or not, that's gonna kind of depend or determine how quickly these tools will wear with bad power as well.
Exactly. Yeah.
So if you got a dirty assembly, there's a lot more energy that needs to happen in order for this to turn, or the motor itself to run the way it's supposed to. And so I guess, without that, you burn it out. You can burn it out in a day. You can burn it out in an hour. You can burn it out after
Just
10,000 volts.
Or you can just blow it just out of
the box. You can
which
blow-
happens sometimes
which
too.
happens more often than not for you.
Yeah, for sure.
Usually during a demo.
Yeah, it usually happens during
Yeah.
a demo. So starting as a technician, now you're an operations manager, but this is something that you've seen as long as you've been here. And
All the way through.
All the way through, and it looks consistent when it comes to your workbench, correct?
Yeah, more often than not, it's you'll find a degradation in the brushes themselves. We'll get a close-up on this afterwards. Whether it's heated up to the point that some of these leads in here are discolored. They're supposed to be a nice bright copper, and they get really dark, and then ends of them turn silver. Sometimes they heat up to the point that these little springs that provide positive pressure against these commutators here, they will actually warp and get kind of bent because they heat up so much they lose their integrity.
So if I look at this, I mean, this one in particular, this one looks good, but after having talked with you about it, you look at the different colorations.
Yeah, I mean,
in
you can
this
see it's got
copper.
plenty of brush life. It hasn't been worn.
Right.
Hasn't been worn at a weird angle for too long.
Like
But
this one
it's
is.
definitely the color. I'm not really looking at the life that's left in the brush itself, more or less the quality
color.
of it.
And the quality.
Yep.
So this one, you can tell it's been beat up just by this. But looking at this one looks pretty similar to a new one.
Yep.
Except for the coloration, as you had pointed out.
Yeah, right when you get down towards the brush side, which is going to see the most amount of resistance. It usually starts in the armature here, and you can see it will heat up to the point of failure. There's supposed to be quite an amount of brass here that the brushes actually touch, and you can see they're missing here on this one.
Yeah.
It's
That
mainly
looks
due to
pretty-
heat.
That is due to heat. That is
Yeah, due to
crazy.
heat, which I say heat. I'm referring to power at this point, because with lack of power or too much power adds resistance, therefore heat, which
Yeah.
can really, it'll melt it.
And this one looks almost like this one,
Mhm.
right? If I were, because I'm I'm not the trained eye. Well, I am now because we've worked together and you've
Yeah.
pointed these out to me. But if I were to look at this, I'd be like, oh, that looks normal. So can you
Yep.
point out the differences in this?
I
This
can.
is a good
Yeah.
one. This is a burnt one.
Well, this one's brand new. It's never been run. So these brushes are made out of graphite. So you're gonna get a little bit of coloring on the commutators itself when the wrench just runs normal
Okay. So
normal
this is
power. So
normal.
this
Okay.
this is pretty normal. It's a little dark, but that's okay. Depending on the assembly you're tightening and what wrench it came out of, it's got a different value. So
Okay.
it could be a little bit darker.
So this is why this is just regular copper color.
Yep.
There's nothing
Brand
on
new.
it. Brand
Never
spanking new.
never
Okay.
been running a tool.
Okay.
This I wouldn't pull it out of the motor and say, oh, this is a bad one out of the gate. There's a few tests that we do to it. One being a continuity test, where we test the commutators all the way through to make sure that there's continuity through each coil.
Okay.
And in that, I believe this is what made this one fail. You can, if you feel it with your finger, you can feel a little bit of a raise right there.
Hmm.
That thing's starting to let go.
Oh yeah.
That's gonna wear a brush very quickly. Just like a knife is going right over it. Like I said, it's graphite, so it's pretty brittle and will fall apart. So this I'd call it good until it fails the continuity test, which it looks like it did here. There's also a portion in here that you can see a couple of these leads in the coil is actually severed and cut, and one of these over here is a little melted. It's gotten to the point where it's heated up a ton, where it kind of got black, carbon covered, and right here it's actually severed of the coil. So when we do our continuity test, we're definitely going to have a failure somewhere in this commutator stack, I guess we can call it.
Gotcha. Okay.
Yeah, it's a little bit inside baseball for this, but that's what we have.
Awesome. Awesome. And then it also looks like even on this side, it looks like there's a little bit of grinding on.
Yep, we definitely assess gearing. This doesn't look too bad. I've seen some that it's usually when it gets really sharp is when it's at its almost failure point. I would pass it on this side for the gearing itself.
Mm-hmm.
This is the first line of contact into the gearing of the tool. So first and foremost, this is what we look at first, and then we actually will be able to take the motor apart to assess any type of wear thereafter. But this is looking pretty decent right now. I've seen some that are a little sharper, but you definitely can see where it does wear.
Yeah. Yeah, you can
There's
see a little
line
bit. Yeah, the line. So,
there.
what else would you see in a motor that would indicate that it was bad? You know, what we call bad power, not clean power.
It could be well, these garters themselves, they wrap around a post that these brushes then feed through,
Okay.
and that's what's supplying the power through the stator into the motor itself. And so what happens is often this piece and the little guide wire that we have here, these two will fail more often than not right out of the gate. That's kind of your first line of failure. Afterwards, if you continue using it or keep repairing it using the same type of bad power, you'll end up catastrophic failure.
Okay. Awesome. Wonderful. And so not only is it the stuff that we plug into that can be bad, and before we move on to the next topic of, quote unquote bad power,
Sure.
One thing that we did run into on a job site was plugging into the trailers on the job site, even though that says that it's a specific voltage that it's giving out.
Sure.
It can also not be
Again,
accurate.
has internal components inside these office trailers or
Yeah.
job trailers that they have an inverter in there that
Mhm.
kind of is regulating power as well.
Yep.
That might have a little bit of a different output to it than what's rated on the plate after months or years of use. Something could have failed in there at some point. It's just one of those things you have to consider could be the cause of your failure.
Yeah. And I think a lot of it too was the way I looked at it was there was a lot of stuff running in that trailer. We were
Yep.
in Texas.
Oftentimes you have an HVAC unit that's
Yeah,
running AC
it
inside
was,
that's
yeah.
drawing off of its condenser and compressor.
People were on
It's throwing
their
voltages. Yep.
computers. On the internet.
Charging your cell phone,
oh, yeah,
any type
yeah.
of draw or anything added on top of these tools will not help them.
Yeah, and I believe a lot of that was a factor in that too. So, and then there's the next factor that we were going to talk about is the cord extension cords.
Yep.
So we do have recommended or suggested cords that we recommend, and the reason why we do that is kind of the same thing. Like it requires certain amount of amperage and
Certainly. So when you have it's not necessarily just your generator. It's not just your wrench. It's what's in between it.
right.
Not only the powered portion or the tool side, it's what's connecting it that really matters to us. You have to adhere to a certain cord gauge as well as length in order for specific models in order to provide accurate power for it. If you run any longer of a run of cord, you get too much of a loss in amperage and a loss in voltage, and you're now making the motor of the tool struggle to receive power. If you're running too short with too big of a gauge, not necessarily much of an issue, but we would like to keep it within these specs if possible.
Yeah, that makes sense. And it is in the owner's manual too, from
page 14
from the actual manufacturer of the tool, Tone. They do recommend that as well, and we just kind of gone a little bit further with different lengths as well.
Sure,
so
yeah.
it's in there. It's in the owner's manual, but we have it everywhere. We have it on our website. We have it inside the tools. But like we stated at the beginning, not everybody pulls out those owner's manual. I'm guilty of it too. I don't always read the instructions. But I just want to bring this to light because a lot of the times when people call in, they get really frustrated with the questions that we ask. And we ask them for a reason because we want to, number one, just make sure that their job site is running efficiently and that they're not having to have it go down, because that costs money for them. But it also costs money for them to send it in.
Of course.
Shipping these things are not cheap, and then they have to pay for the repairs, and then which you guys
oftentimes is brushes, garters, armatures itself, and any other wearable parts inside of it at the moment of the failure.
Exactly.
And so we're trying to prevent the failure so that these parts aren't worn as quickly or prematurely.
But it's all also just kind of trying to eliminate some of the things. So we start there because that's typically where it happens and where the issues start is there. And then we start to dig a little deeper and look into the process of their installation methods. But typically, I want to say about 85% of the time, it comes down to these two things. It's what they're plugged into and what kind of a cord are they using. So, and a lot of the times too, these extension cords are old.
Yeah, same thing as the generator itself, same thing as the tool, depending on how long you've been using it, with bad power or any type of power. It's all wearable parts, right?
Yeah.
So as you have an extension cord 10 years later, it's not going to always have the same amount of voltage or amperage allowed to run through it.
Correct.
Or be worn in kind of a weird way. I had this one instance where I advised the customer they were running too long of a cord. Proper gauge, but too long. And I asked, well, is there a way that you can move your power source closer? Oh, yeah, it's one of these suitcase generators. We can move it a little bit closer. Great, do that. Cut your cord a little bit, dress the end for a new plug it in. We should have better flow of the electricity.
And not only that, I mean, these are light. You can put these in a boom lift with you.
Yep.
Yeah. So they are very easy to use, very light. They call them suitcase for a reason.
Yeah.
So, these are great. The thing to think about with all generators as well is that there's just one tool plugged into them, not multiple. So one tool at a time in these.
Even if they give you multiple outlets.
Which I think that one does. Yeah. You need to just do one tool. You don't want to be welding around the area as well that you're using these tools, with any kind of tool really, because it can find its way.
Yeah, there's an electrical interference that can happen just even in close proximity with a welder going.
Exactly. So you want to just make sure that you're not welding at the same time that you're using these tools. So I think it's a lot to it's a lot of questions to answer when they call in, and I understand the frustration. But I think we just have to eliminate everything to help it from happening again. And I know at the end of us trying to troubleshoot with the customers, they are happy that we did that. At first, it's kind of frustrating because now they have to answer all these questions. But then eventually they appreciate it.
Once there's a solution from it, usually they're like, oh, I'm on board with you now.
Yeah, we're
Mm,
not electricians, but we do
no,
know that it's enough to damage these
of
tools.
course.
And so that's why, we're able to say, okay, well, the owner's manual says this, and this is the reason why. But if they need us to go any deeper, when it comes to the technical stuff of being an electrician, that's not me.
Of
But the
course.
fact that we call it not clean power, it has to be clean power for these to work.
Hmm.
That's what we mean. It's got to be plugged into the right things, and it's got to have the correct extension cord engaged.
Yep.
Awesome. Well, thank you for spending the time with us, with everyone today, just sharing
Yeah,
all
of
of your
course.
knowledge and what to look for. It sounds simple. It can be simple
Sometimes it's an easy
but
answer. Other
sometimes.
times it's not so much.
Right, right. So hopefully this is helpful for everyone. So thank you.
Yeah. Thank you.